Well, pre-calculus students, as always, good morning, good afternoon, or good evening. We're going to start into what is now the second half of Chapter 2 as our next unit, covering 2.5 through 2.8. And what we're going to do is actually look at really finding zeros of polynomial functions. I know we've kind of done some things with synthetic division that will look real similar now to what we're going to do, but now we're going to really kind of put everything together in section 2.5. So first off, one of the key things is finding what are the rational zeros of a polynomial. I mean, there are certainly going to be some imaginary solutions, some things you're going to have to use quadratic formula for, but you always want to start out with what are the rational zeros, meaning either the integers or fractional solutions that are much easier to find. So if a polynomial has integer coefficients, every rational zero of the function has the form a rational zero equals p over q, where p is the factors of the constant, q is the factors of the leading coefficient. So the possible rational zeros are the factors of the constant over the factors of the leading coefficient. And I always list these out, and you'll see the reason why I do this before any question where you are asked to solve. So find the possible rational zeros. Well, again, we're going to do our, and also the other thing, it's plus or minus p over q. I know we didn't explicitly put that here, and I'm even going to put parentheses there. So plus or minus. Now, the factors of the constant. Well, the constant is whatever that value is at the end. What goes into 6? Well, 1 and 6, 2 and 3. Over the factors of the leading coefficient. Well, our leading coefficient is 2. Only things that go into 2 are 1 and 2. Now, one of the things I also like to do is actually list all of these out. Well, what this means is you're going to take all of these values divided by 1 and all of these values divided by 2. So 1/2. Now, there will often be some repeats. 6 divided by 2 is 3. You don't need to list it. 2 divided by 2 is 1. Don't need to relist it. 3 over 2, though, is a new value. So you have these 4, although technically 8, values that are possible integer solutions, and then these 4 values, because of the plus minus, that could be fractional solutions. So again, as we go a little further, you'll even see why we do this. So if we actually now look at, finding some of the rational zeros, well, if we have something like x to the third plus x plus 1, again, I am going to always start out listing what are the possible zeros. Well, this one's real quick. What are the factors of 1? Well, 1 and 1, I guess, technically. Leading coefficient's also 1. What are the factors there? Well, it hasn't changed in the last 10 seconds. Again, 1 and 1. So our only possible rational zeros here are positive and negative 1. So what are we going to do to figure out what works? Well, we're going to use synthetic division. And, whether you start with the 1, whether you start with the negative 1, the main thing you do have to remember is include that 0. So bring down the 1, add, multiply, and add. Okay. Well, we have a remainder of 3 here. What does that mean? It means 1 isn't a possible zero. From here, now we'll use negative 1. Again, bring down the 1, negative 1, we'll add, multiply, and add. Well, again, one of the reasons we always start out with this example is we want you guys to see, certainly, that as we work through both of these, it is possible you won't have any rational zeros. Doesn't happen real often. basically what that means is all of the remaining zeros, they're going to be some sort of either irrational or imaginary type of solutions. But this is one where, we do not end up with a rational, meaning fractional or integer zero. So, again, just the first two are kind of lead-ins to the last two that are where we're really going to do a lot of the math involved with this. So, rational zeros here for 2x cubed plus 3x squared minus 8x plus 3. I mean, one thing you can always do if you have a, four-term polynomial like this, you could always look at to see, might grouping work? I mean, if you actually tried to group here, you could see pretty quickly, no, it won't work. So, we have to do synthetic division as our alternative if something won't factor. So, again, I'm going to start out by listing, okay, what are our possible zeros? 1 and 3 are the factors of 3. 1 and 2 are the factors of the leading coefficient for an overall list of plus or minus 1, 3, 1/2, and 3/2. So we don't have a huge number of these, although at the same time, we still have 8. There are only a maximum of 3 zeros. So, I mean, with 8, only 3 of them at most are going to work. I mean, you still only have a 50-50 chance that any of these are going to work. So what we can do to help you narrow down, okay, which one of these should I use? Well, I'm going to plug that into my graphing calculator. And let's see, you can see that looks like -3 is an option to start with. We will always need to see all work to verify solutions. The graphing calculator will be something that can at least help you narrow down your search. So, -6, -3, 9, 1, -3, which is a remainder of 0. One of the nice things about this is, when you look at this and see, okay, it does cross at -3, you even have kind of a built-in as you're going. I mean, every now and then it's easy to do, especially if you're working quickly in your head, if you've made a real quick mathematical mistake. So we have shown one solution is x equals -3. Well, from here, now what I can do is plug back in variables, 2x squared minus 3x plus 1. We're now down to a quadratic. So, always look at first, will it factor? What multiplies to 2 adds to -3? Well, -2 and -1. So 2x squared minus 2x minus x plus 1. And now we can group. We'll factor out the 2x, x minus 1, factor out the -1, also x minus 1. So we have our check right there that so far we're good. X minus 1, 2x minus 1, and so the other two solutions, x equals 1 and x equals 1/2. Sometimes when you look at this, because the window is not real zoomed in, it almost looks like there's a double zero somewhere in there. It actually does apparently cross in 2 spots. And for 1/2 and 1 are very close together. That's why you couldn't really see right there that, yes, they are, both zeros. So that is an example, a little more into, okay, what's the full process like? And then the next and final example in the first half here will be why we actually will say yes for something like this, use the graphing calculator to help you, because when I list for f of x equals 15x to the 4th minus 68x to the 3rd minus 7x squared plus 24x minus 4, find all the real zeros, well, you're going to see that the possible zeros is actually quite a list. Factors of 4 are 1 and 4 and 2 and 2. Factors of 15 are 1 and 15, 5 and 3. Well, that means plus or minus 1, 4, and 2. It also means 1 15th, 4 15ths, 2 15ths, 1 5th, 4 5ths, 2 5ths, and I'm actually running out of room here. Also 1 3rd, 4 thirds, and 2 thirds. Well, here's where, again, the graphing calculator, it's nice to have because we've got 3, 6, 9, 12, plus or minus. There are 24 possible rational zeros. There's at most 4 rational zeros. Well, at best, you pick one of these, you have a 1 in 6 chance it would have worked. I mean, at least with this one, you had, there's 8 values, 3 zeros, you had a pretty decent chance of picking one there. So, what we're going to do again, go back into your y equals, clear out whatever's in there, and enter in that new function. Whoops. And then we'll graph it. And here is an example where what I am going to do, because some of these are difficult to see. Now, one of the things I also want to talk about is right here. You can see 1, 2, 3, 4. There's one between 4 and 5. Nothing on our list is between 4 and 5, and that tells us we're probably going to have to do the quadratic, meaning there are irrational zeros that won't be on this list. But what I am going to do is go into my window and shrink it down a little bit. So when I look here, it looks like, there's nothing, really looks like nothing's beyond -1. So I'll use a window from -2. And again, that one was between 4 and 5. And now suddenly it's a lot easier to see. So, as far as some options, unfortunately the bad news is, yes, we are going to have to use a, fractional value. There are no nice, neat integers. Well, when I look at this one, I can see right here, and honestly, if you want, because we know there's nothing between 4 and 5, you could even shrink your window down more, and that's what I'm even going to do here. Just -2 to 2, because the only 3 that might actually be rational are these fractions. I'm not even going to worry about that other one for now. I'm going to actually start with this one right here. There's something between 0 and -1. You can see it's over halfway. Well, when I look, it's probably -2 thirds. So I'm going to start my synthetic division with -2 thirds. And these numbers aren't going to be the nice and neatest to use, but bring down the 15. Let's see, -2 thirds is -10, -78, 52, 45, -30, -6, and +4. So our remainder, once again, is 0. So we have verified or found, whatever you want to say, one of the zeros at -2 thirds. Now, again, you can always look to see, will it group? If you were to use 15 and 78, 45 and 6, I can just look at those values and see there's no way these numbers are similar enough to where it's going to factor by grouping. Sometimes, if you have a quartic or 4th degree polynomial, you do synthetic division once, then you are able to group. This is not one of those instances. So now what we're going to do is come back and look at this. Now, this one I was pretty confident about -2 thirds. If you aren't as confident about, okay, what is this one? You know, when I look at this one, it's probably not quite halfway. So, you know, again, maybe it's the -2/5. This one right here, you know, maybe it's, or not negative, but positive. This one, you know, probably, if I were guessing, it's going to be 1/5. Well, you have a way, if you don't ever want to just randomly guess at the fraction, you can also, like when we found the max and mins, you can do that second and calculate the trace functions and actually find a 0. I'm going to look at this one. Again, the main thing is make sure left bound, you're to the left of where it crosses. Right bound, again, as long as you're to the right of where it crosses, do not go past the next 0. And again, you can see at guess, the arrows are kind of pointing inward where that one is. I'll hit enter one final time, and sure enough, it was the 0.2, which is 1/5. But again, you know, it saves you a little bit of, you know, random work if you use that solving function. So bring down the 15, a fifth of that is 3, -75, -15, 30, +6, and a remainder of 0. So we have now verified x is -2/3, x is 1/5. Okay, with what's left, 15x squared minus 75x plus 30 equals 0. Well, I can tell you right away this is not going to factor. Now, if you want, when you do quadratic, you could make this really ugly and use these values as is. Or divide everything by 15. So x squared minus 5x plus 2 equals 0. Now, quadratic formula is going to be a lot easier to do. So opposite of b is 5 plus or minus square root. B squared is 25 minus 4ac all over 2a is 2. So 5 plus or minus 25 minus 8, square root of 17 over 2. Well, these are those two values, which right here, I know this one's right around 0.5. If you actually worked out 5 minus radical 17 divided by 2, it's probably going to be in the ballpark of 0.5. If we go back to the original graph, that's 0 between 4 and 5. If I do 5 plus radical 17 divided by 2, again, it's going to be between 4 and 5. So you will usually or often end up with zeros that aren't on our rational list. Again, sometimes they could be real irrational values. Sometimes they're going to be imaginary. You know, we'll look more at that in the next half of the section, but that completes the first half of 2.5.